Hi, welcome to the video solution for Edexcel past paper solution. This is Edexcel IAL June 2019 Unit 4, the second video of the series. So let's start. Question number 15. The photograph shows the path of an electron beam in a fine beam tube. So this is a beam tube here. And the fine beam tube contains helium gas at a very low pressure. When electrons strike the helium atoms, the resulting excitation is responsible for the glow of tracing the path of the electron beam. The electron beam is emitted downwards from an electron gun. So if you see, this is the electron gun here. An electron beam is released or fired downward here, something like that. And okay, the electron gun consists of a heated filament above an anode as shown. This is the second diagram. So anode, we have a heating filament, and there is a potential difference of 135 volt between the anode and the filament. Question is, describe how an electron beam is produced. So basically, whenever we need to produce an electron beam, in general we use a filament and we apply some voltage, high voltage across the filament. So due to heating of the filament, electrons are emitted. Once electrons are emitted, they start gathering here, but due to potential difference on anode, they start moving or accelerating toward the anode, and then they forms a beam. So that's how we get an electron beam, by heating a filament. Sometimes we also call thermionic emission, and the anode. So we have electric field, then electrons are accelerated to form an electron beam. Second part, show that the speed of electrons leaving the electron gun is about 7 × 10⁶ meters second inverse. It's quite a straightforward and easy question, because we need to find speed, and we have a charge particle. Remember, if voltage is given, then energy gain is equal to voltage times charge. So energy gain of a moving charge under a voltage V is V into Q. You just multiply voltage with the amount of charge, you can have energy. In this case, energy is half mv squared is equal to V into E. E is electron charge. So now you can make V as a subject. So you have a V is equal to 2VE upon m square root. And if you substitute all the numbers, so 2 into 135 volt into charge of electron 1.6 10⁻⁻19 divided by mass of electron given in your data sheet. So 9.11 10⁻⁻31 square root, and then you have a V is equal to 6.88 into 10⁻⁶. You can round it off, 6.9 into 10⁻⁶ meters second inverse. So this is how you find the speed. There are steps that I did in detail. You can skip any step, whatever you wish to skip. Part B is the electron beam follows the path shown in the photograph. A horizontal magnetic field is applied in direction into the page. Show that the particle of momentum P follows the circular path of radius r given by this equation. If you recall, a charge moving in a magnetic field experiences a magnetic force, due to which the particle moves in a circular path. So magnetic force, this is just for your information, that magnetic force acting is equal to the centripetal force. CPF, it's just a short form I'm writing to save the time. So magnetic force acting on a moving charge acts as a centripetal force. So magnetic force, because charge particles are moving perpendicularly, so magnetic force is BQV. It is better to use capital Q, charge, because Q is given. So I am using BQV. This is the velocity, and centripetal force is mv square over r, and 1v gets cancelled, and if you make r as a subject, so r is equal to mv upon bq, and m is a mass, v is the velocity, so this is p upon bq. That's how you can derive. Calculate the value of B. Diameter of circular path is 7.3 centimeter. Remember, this is a diameter, so D is equal to 7.3 centimeter. You can convert into meter, divided by 100, 0.073 meter. And we need to find the B. So make B as a subject from this equation. So B would be equal to R, B would be equal to mv by rq. So we need mass, which is given, velocity we have found, radius we can find from there, so r is equal to d upon 2, and q is a charge on electron, so B is equal to mass of electron is 9.11 10 to the power minus 31. Velocity we found is 6.9 10 to the power 6 divided by r. R is the radius, which is 0.0365. You can solve from here. And then 1.6, which is charge, 10 to the power minus 19 coulomb. Once you solve that, then B would be equal to 1.1 into 10 to the power minus 3 Tesla. This is the magnetic field. The diameter of a circular path was measured by holding a meter rule in front of a tube and taking a photograph as shown. So here is that this is, you can imagine this is the circular path of radius, some radius, and you need to measure that. So we put a ruler in front of a tube and we use a camera. So discuss the suitability of this method. The first thing is we are using meter ruler. That means the resolution of meter ruler is 0.1 centimeter, and the measured quantity is greater than this, so we have a very less percentage uncertainty. That means using the idea of a ruler is good. We can have a reliable measurement, but the problem is with camera, because we are using camera at the center. So if we take a picture and we need to find the diameter, and clearly you can see that we can have a parallax error. So in this setup, camera will give us a reading of end of the both end of the diameter with some parallax. Suggests why the electron beam continues along a path of decreasing diameter with decreasing intensity. So generally there are two reasons. Number one, when electrons are moving, they are colliding with the helium atom. So number of electrons are continuously decreasing, and they are also losing energy when they are revolving. So losing energy and so that's why losing energy. So radius is decreasing, and because electrons are absorbed by the helium atoms, so intensity is decreased. The photograph shows an arrangement for investigating charge known as the shuttling ball. So we have a system in which a ball coated in conducting material is suspended on a very long insulating thread between metal plates. A potential difference PD is applied across the plate so that plate X is positively charged and the plate Y is negatively charged. When the ball is touched against plate Y, which is negatively charged, it gains negative charge and is attracted to plate X. When the ball touches the plate X, the charge is transferred, the ball becomes positively charged and is attracted to plate Y. The ball continues to move between the plate. Assume that presence of the ball does not affect the field of the plate. Sketch the field between plates on the diagram below. So you need to sketch a field line between the two plates. We have two parallel plates, 2 marks question. So make sure that for the safe side you draw at least three or four equally spaced line from high voltage to low voltage, or from positive plate to negative plate. Make sure that equally spaced arrow from positive to negative, and arrows should touch the plate. So I cannot have an option to draw a straight line, but you must use ruler, and make sure that you draw arrows touching both of the plate, equi-spaced arrows, straight arrows, at least 3, and it is good for the safe side to draw 4 arrows. An arrow should touches the plate at both ends. If you draw arrow something like this, you might lose 1 mark because this is not acceptable. Explain why the charged ball experiences a horizontal force of constant magnitude while it is between the plate. Because the charge, the force experienced by the charged ball is F, which is F is equal to EQ. This is the definition of electric field intensity. E is equal to force per unit charge. So force acting is F is equal to EQ. You know that in the previous part it is said that the E is constant, uniform, and charge given to the ball, once it is receive a charge, it will also be a constant charge. So that's why the force is constant. Okay. The ball is initially at rest touching plate Y. After it leaves the plate Y, the ball accelerates uniformly from plate Y to plate X. Remember, this is the plate Y and this is the plate X, and we have a ball here and it is start accelerating towards plate X. And mass of the ball is 2.7 gram. Show that acceleration is about 0.2 meter second minus 2. Distance between the plate is 9.5 centimeter. Potential difference between the plate is 5000 volt. Charge on the ball is 11 nanocoulomb. So if you do some mathematics or approach, you know that force acting, because we need to find acceleration and we are giving charges and voltage and we have a 2 parallel plate. So we know that force acting on the charged particle F is equal to E into Q, and F is MA and E is V divided by D, V upon D. This is another formula for electric field intensity between the two plates into Q. So clearly acceleration would be equal to VQ upon MD. And now we have everything to find acceleration. A is equal to 5000 into Q is, because this is charge given 11 nanocoulomb, 10 to the power minus 9, divided by mass, and mass of the ball is 2.7 gram. So you can say that this is a 2.7 divided by 1000, so 0.0027 kilogram into D. Distance is 9.5 centimeter. so 0.095 meter. And once you solve this, so acceleration would be equal to 0.214 or 0.21 ms minus 2. This is the acceleration of the ball. Calculate the momentum of the ball as it reaches plate X. So if you need to find the momentum as it reaches at plate X, if you see that this is the plate Y and plate X, so we have configuration. This is plate Y, plate X, and ball was at rest and it is moving toward plate X. It is because it is accelerating, so speed is continuously increasing, velocity increasing when the ball is about to touch. At that moment the ball has some speed v. That's what we need to find if we need to find the momentum, because momentum p is equal to mass into velocity. Mass is given in the previous part. Velocity we need to find when the ball is just touching the plate X. So in order to find v, we have acceleration and we have that distance between the plate, which is 9.5. The idea is distance traveled by, see, because we have acceleration, so we are going to use sweat equation to find the final velocity. Initial velocity is 0 and final velocity we need to find so that we can find momentum. And how do we find that? Because ball is accelerating. Remember, do not use S is equal to Vt. This is the equation that we use for uniform motion when acceleration is 0. In this case we cannot use that to find V. Of course we don't have time as well, so this is a different story. But we have acceleration, we have initial velocity, we have we can find final velocity because distance traveled we can find from here. Remember, distance traveled is not 9.5 because we have a diameter here. So distance traveled by the ball is 9.5 minus the diameter. So first we find the distance traveled. So S is equal to 9.5 minus 4, which is 5.5 centimeter. This is distance traveled. Now we can use the sweat equation. V square is equal to U square plus 2AS. So 0 initial velocity plus 2 times of A. A is acceleration that we found in the previous part, 0.21 into S. S is the distance, 5.5 divided by 100, 0.055. This is V square. Once you solve this, so V is equal to 0.15 meter second minus 1. Now you can find momentum. P is equal to M into V. And mass is given, I guess 27 gram, so 0.0027 into velocity 0.15. So momentum of the ball is 4.05 into 10 to the power minus 4 Newton second, or 4.1 if you wish. The ball is in contact with the plate X for a 0.95 millisecond. Calculate the average force acting on the ball during this time. Assume that the ball hits the plate and leaves the plate at the same speed. So the idea of finding force and momentums are given and time is also given. So F is acting mv minus mu divided by time t. In this case, because momentum is a vector quantity, so in fact this is 2mv divided by t. The reason is because when you find the change in momentum, so this is one momentum mu, and when it returns with the same speed, so mu, the change is 2mv if you okay with the vector quantity. So this is 2mv divided by t. You can find force. So F is equal to twice of, again, mass is mv. Mv is the momentum. Don't need to put mass and velocity because we have found the momentum. So 4.1 into 10 to the power minus 4 divided by time is 0.95 millisecond, 10 to the power minus 3, and then you have a force acting. F is equal to 0.863 Newton. You can round it off 0.9 if you wish, or 0.86 Newton. Question number 17. The photograph shows an electric fly zipper racket. The racket has two metal meshes. When a fly is between the meshes, the user press a button and potential difference of 1500 volt is applied between the meshes for a short time. This potential difference causes a current in fly is turning it. A student thought that the racket must contain a capacitor. To investigate this, he connected a resistor with the high resistance between the meshes. So this is the system. We have a R here and upper and lower meshes circuit. Okay. So the student pressed the button and used a data logger, to record how a potential difference across the resistors varied with time. The students obtained the following graph. So we have a graph of decreasing potential difference with time. In second, describe how a graph of potential difference against time can be used to show that the racket contains a capacitor. Your answer should not include calculation. We do not need to do any calculation. We need to give some idea, or one idea at least, to show that if there is a capacitor, so this is the decay graph of a charge of a capacitor, or voltage of a capacitor. So remember, the discharging of a capacitor is exponential decay. Exponential decay. And exponential decay means the change of quantity on y-axis, like here, delta V upon delta T in some time interval. Let's call it delta V1 upon delta T2, and delta V2 in some other time interval, delta T2. But delta T1 must be equal to delta T2. So this change must be same. So that's how we defined exponential decay. So this is one method that a student can find the rate of change of voltage in two equal interval of times and compare the values, if values must be same, if it is really a discharging curve of a capacitor. Or there is another way that you can plot graph of log of V against time. So it should be a straight line with negative gradient. So you can say that the change in voltage in two equal intervals of time must be same. Or you can give an idea about log of I or log of V against time graph. So log of V against time, it should be a straight line with negative gradient. So it's your choice, whatever you want to write. Show that capacitor has a capacitance of about 10 nanofarad. Use value from the graph. Resistance of the resistors is 12 milliohm. So the idea is there are many methods that we can find the capacitance, but because graph is given, so we can find half-life, and half-life of this curve can be used in half-life formula. So if you see that this is around 1440, I'm just taking 14, I guess, or 1440, 1500. I can take a 1500 as well. So 1440 if I choose, and half F 720, so 600, and this is 200 divided by 540, so 640, 680, and then 720. So this is the time that we can have 0.0, 0.1, 0.11, 0.12. So this is half-life, T half, 0.12 second, and we can use half-life formula. So we know that half-life T half is equal to RC ln2. That means capacitance is T half divided by R ln2, and now T half we have found is 0.12 divided by R. R is 12 million, 12 mega, 10 to the power 6 into ln2. So capacitance is around 1.44 into 10 to the power minus 8 farad. It is capacitance, and you can shift decimal right side. So C is equal to 14.4 into 10 to the power minus 9 farad. So C is equal to 14 nanofarad. So it is close to 10, you can say that. To ensure safety for humans, the maximum allowed charge, stored charge for fly zapper is 45 microcoulomb. Show that this racket operates within the safe limit. So you just need to calculate the charge. So Q is equal to CV, and Q is equal to CV. CV have already calculated 14 in nano minus 9 into voltage, and voltage is 1440. So the charge is 2.016 into 10 to the power minus 5 coulomb, and you shift here. So this is 20.2, 20.16 or 20.2, 10 to the power minus 6 microcoulomb, which is less than 45 microcoulomb. So yes, it is safe. Calculate the energy stored on the fully charged capacitor. So the energy stored, E is equal to half of CV squared, and C is 14 into 10 to the power minus 9. Voltage is 1440 square, and then energy storage 0.0145. So you can round it off 0.015 joule. So this is the energy stored. The potential difference falls to about 5% of its initial value in less than half a second. Explain why measurements were made using a data logger rather than a digital voltmeter and the timer. So the reason is because there is a very quick decrease in the voltage, less than a half second. So time interval is very small. So in order to read reading from voltmeter and the timer is almost impossible. We cannot measure the simultaneous reading of voltmeter and timing. But data logger can read both reading of voltmeter and timer simultaneously, as well as it can record more voltage decrease or more voltage reading during a small interval of time as well. So that's how data logger is used. The capacitor is charged using a 5-volt battery. A circuit in a racket produces a small alternating potential difference. This circuit is connected to a coil wound around an iron core. A second coil around a core is connected to a capacitor charging circuit as shown in the diagram. So explain how this arrangement causes a current in the capacitor charging circuit. 4-mark question. It is again a typical question of unit 4. It's all about change in magnetic flux producing induced EMF. So because, how do we know? Because we have two coils. So we have one coil connected with some power supply, and we have a second coil not connected anything but the outer circuit. So how do we explain? Because this is the coil number 1. If you see the gray, this is the coil number 1, which is connected with the alternating power supply, and this is coil number 2 to the circuit. So what is happening here? Due to current passing from this coil number 1, this coil 1 is going to produce a magnetic field. So we have a magnetic field of coil 1. This is just a random arrow I'm showing. So we have a magnetic field, and this magnetic field will, also associates with the secondary coil. So secondary coil has a magnetic field linked with the first coil, but we have alternating current. That means this magnetic field is switching all the time. So we have a change in magnetic field. So the second coil magnetic flux is also changing. So whenever flux is changed, an induced EMF is produced. So in the second coil, due to change of magnetic field of the first coil, which is linked with the second coil, also causes an EMF to induce, and current is going to flow, induced current. And this current can be used in the circuit to charge the capacitor, because if there's some capacitor, so the current and the circuit is complete. So that's how we can charge a capacitor. That's it for this paper. Thank you very much. I hope you understand. Have a nice day.